Hi everyone! In this video, I'm gonna show you how to write down measurements of your planes in such a way that everyone understands them. There are several ways of doing this, and we have to be aware of the different options. So let's take this plane as an example. On this plane, we have the strike and the dip direction. You can see that the strike has two different senses. One of them is roughly 30 degrees, this one. And the other one is roughly 210, this one. These two numbers describe the same strike. The red arrow is the dip direction, and it's perpendicular to the strike. If we check with the compass, we see that the azimuth of the dip direction is 120. Unlike the strike, there is only one way to describe the dip direction, 120. The dip angle in this example is 20 degrees. The first way to write down the information about our plane is using the dip direction and dip angle. We already mentioned that the dip angle is 20 degrees. And in our compass, the dip direction will look like this. It's 120 degrees. So, if we use the dip direction, this would look like the following: 20 degrees towards 120. So, the first option is use the azimuth, in our case, 120. But other people find other way more intuitive, and in this case is using either the north or the south as reference. In our case, south is closer, so we will use this one. There's a distance of 60 degrees towards the east. So if we write down this in a different way, it would be 20 degrees, because that's the dip angle, towards south, 60 east. For the dip direction, both measurements mean the same. Apart from the dip direction, we can also indicate the measurement using the strike. To do this, we have three different ways. And to understand why, let's go back to our example of the plane. As previously mentioned, this is the strike of the plane. It's important to realize that there are two different senses. One is 30, and in the opposite direction we have 210. Both numbers describe the same strike. On our compass, this will look like here, 30. And as this is also a directional data, we can write it down like north, 30, east. On the opposite sense, it will be 210. Once again, if we take as reference the south, it's south 30 west. We always start either with south or north. These are all the ways of writing down this information. And now, which one do we choose? In this case, it would depend on the notation method we are using. So, in our example, the strikes is 30 and 210. For the first 180 degrees notation, we will pick the lowest value, in this case, 30. A common notation is to use the smallest strike value. In our case, it's 30, and in every case, we are going to use only the first 180 degrees. So we are going to call this notation first 180 degrees. In this case, we write down first the strike. And remember to always write 3 different numbers. And then the dip. But we need one more term in this notation, because with just the strike and the dip angle, there are still 2 options. The plane could be like this, but also like this. This other plane has the exact same strike and dip angle, but it's clearly not the plane we measured. Therefore, it's important to always add the quadrant in which the plane is dipping. For us, that would be southeast. So, to finish our documentation, we have to add the quadrant. If we don't do this, our measurement is completely useless. There's another way to write this. In our case, north, 30 east, and the rest would be the same. Using only the first 180 degrees leaves some ambiguity in our measurement. This can be resolved by making the strike depend on the dip. And that's the main advantage of the hand rule. For all planes, the dip direction is always perpendicular to the strike. You can take your hand and point your thumb in the direction of the dip and your other fingers in the direction of the strike. So, for the right hand rule, my fingers point towards just one of the 2 senses of the strike, in this case, 210. An advantage of this rule is that the strike is linked to the dip, and that only one of the strike senses is valid. In fact, if you use 30 instead of 210 with the right hand rule, that would imply that the plane actually dips in the opposite direction. The strike of 30 will describe a plane that dips towards the northwest. However, our plane that dips to the southeast needs to be used 210 rather than 30. The advantage of linking the strike direction with the dip direction is that if you forget to write down the quadrant, you still know in which direction your plane is dipping. In our case, if we used the right hand rule, the plane would look like this: 210, 20. With this, our plane is completely documented. But just in case, as a double check, we can also include the quadrant, southeast. it's not necessary because we already know that we are using the right-hand rule, just in case. And as previously explained, this is also south 30 towards west, 20 southeast. The left-hand rule works exactly the same as the right-hand rule, but in a completely opposite way. Once again, we have the advantage that we are linking the strike to the dip direction. But in this case, careful, but we have to look at your left hand. Using the right-hand rule, we have just described the plane like this. The thumb is the dip, and my fingers are the strike. The left-hand rule works the same but with the other hand. You can see that you both describe the same plane with the exact opposite sense of strike. Again, the strike is linked to the dip direction. So there is only one correct strike for every single plane. So for this plane, using the left-hand rule, the correct strike is 30 and not 210. So if we write down the measurement of our plane based on the left-hand rule, this would look like 0, 30, 20. Once again, this is enough for our plane because we know that we are using the left-hand rule. But let's include the quadrant as double check. As previously, we can write this plane as follows. In short, these four methods are all the ones existing to write down your measurement. We have the dip direction, first 180 degrees, right-hand rule, and left-hand rule. As you can see, the last three are written really similarly, so you have to specify which method you are using, so people don't interpret your data in a wrong way. If you don't write down which notation you choose, that can lead to an incorrect interpretation of your measurement. Let's say I document this plane using the right-hand rule. I would use 210 to imply that the dip is towards the southeast. However, if I accidentally interpret this strike with the left-hand rule, the plane will dip in the opposite direction, which is wrong. That is why adding the quadrant to the hand rule notation is so useful. It's a safety check that prevents mistakes. These were all the different ways of documenting plane measurements. For a summary, look at the infographic on the topic. See you next time!